Hey, John here. Let's look at the workflow involved with doing the assignments for CompSci 340. Okay, here's the regular old course website. Right down here, we've got a, this is the lecture you're watching right now, homework workflow. This handout right here is the thing we're interested in, okay? I just opened it. It's right here. And we're going to just go through these steps, okay? First thing you're going to do is create yourself a GitHub login if you don't already have one. If you do, you can click sign in and use the one you got, or you click sign up over here and fill out the usual stuff, your email and a password. They're free. Go ahead and create one, all right? You're going to use your GitHub account to receive your homework assignments and hand them in, because the GitHub is going to hold the origin server that you're going to use to manage your files, okay? So I'm going to go ahead and sign in with my existing login. Now, each assignment will be emailed to you as an announcement from Blackboard, and you'll get a URL that looks a lot like this right here, okay? So each assignment will show up like that. And what you do is you click on that link, and it will take you to a new site that you can accept an assignment, all right? So I'm already logged into GitHub. So what I'm going to do is I'm going to change the link to the invitation link, all right, that you'll receive from Blackboard. I'm going to say, okay, accept the assignment. Now it takes a minute. This is the page where the assignment will appear. So give it a little while, then go up here and hit reload. And there we go, we're ready to go. So this link here will be your repo. It's a private repo that only you're going to use, okay? It's okay that this is publicly visible because you have to log in as yourself to actually see and use these files, all right? So this is mine. This is mine, my version. Every student will have their own. This particular assignment will show up underneath Wide and Seek CompSci 340 Spring / and then it'll say Intro to GitHub Dash, and then this is your GitHub login over here, okay? Now the next step in the assignment, open the repo. We just did that. Then create yourself a development branch, right? So remember that there's this main branch, okay? It might also be called master branch. It depends. People are changing the terminology, okay? But what you're going to do is you're going to create a development branch, and on that branch we're going to do our edits, and when we're done we're going to send back a pull request so the TA will merge it back in to the main branch, right? Okay, so how do we do that? Well, you go over here and see where it says branch there, and it says master. We only have one right now. It's called master. If we want to create a new one, we got to say development. Okay, and hit enter. And it'll generate one called development. You can click this now. You can see I have two of it. It says master and development, okay? All right, now GitHub knows there are two branches, okay? You want to do this before you clone it, okay? You can do it afterwards, but that requires more work to let GitHub know about this new branch, okay? Trust me, do the branch first. So what do you got in here? You've got all the files, the starter files, shall we say, of this first assignment, okay? And this first assignment itself is go through the motions to figure out how to hand it in, all right? So we're not really going to develop any code. This is all given to you. What the hard part here is just figure out how to log in and make it go, okay? So the handout that describes what to do is a README file. This README MD file right here is what's being displayed below here, all right? And this is in this repo that was created as a result of that invitation, okay? So you can go down here and it'll say do this, do that, do whatever the assignment you're supposed to do, okay? Now there's some guides here. Your very first time using GitHub, you might want to look at these various guides and how to use the commands and stuff like that. I'm going to go over each command. You're going to see me do this entire assignment. So what I suggest you do, if you don't already have your login all set up in a web browser, next to this video, pause it, make all that happen, and then come back here and resume the playback so that you can go through one step at a time. and actually do this assignment while we watch this video, okay? All right, so we already did this. Here's your link to the invitation, and so on. And we've opened it up, and we've said, I want to accept the invitation. So that's what it's talking about up here. Kind of a chicken and egg problem. You document it inside the assignment that you don't have yet, right? Okay. Anyway, so we're moving along here. Once you accept the invite, you're taken to a page, blah, 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 blah. We saw all this happen. And this is what we were looking at before, introduction to, whatever. Okay. What does it say? Click on the link and work from your browser, or use the command line tools as demonstrated in class, which is what we're doing right now. If you want to go surf around the internet and find command line, or rather graphic tools and things, knock yourself out, I'm going to use the command line version. Okay, we finally get to the point where we're talking about the assignment itself. What are you supposed to do? We're going to add a doc box to some code. Okay, that's already in the repo here, called introduction.cc, this file here. Then we're going to make sure it can build and stuff like that. Okay, now what we're going to do is we're going to create an error in our program. We're going to commit that and try and run it and everything. And what's going to happen is we're going to go through what I consider to be a normal workflow. I'm on my home computer right now, and I'm walking through all this. I'm going to do my work on my home computer, and then I'm going to, think that I'm done and great, and I'm going to go ahead and push it back to GitHub, and I'm going to leave this bug in there, okay? And then we're going to find the bug when we're trying to test it on Hopper, okay? And then we're going to fix it and so on. Again, this should be not out of the question. You need to know how to do all this stuff, otherwise you'll get stuck on a real assignment down the road. All right, so we're going to fake making problems is my point. All right, and then we're going to actually hand it in. Okay, so what are we supposed to do? Okay, the top of this thing, see where it says code right here? Click this, and you need to clone this. All right, remember, we're looking at this, the origin server right now. Now I'm going to go ahead and use HTTPS. And more advanced users can use SSH if you already know how. I'm not going to explain that if you don't already know how to use it. This is more straightforward if this is your first time, okay? So grab the HTTPS link out of here. Go to a nice empty place on your home computer and type git clone. And then put that link in there, all right? This is not the invitation link, okay? Notice this is a different link. This one is the link out of here, okay? Hit enter, and it'll say, okay, I'm cloning. Enter your username. That is my GitHub login. This is my GitHub password. And it will clone the file. So what did it do here? Started with an empty directory. It created this directory and put some files in there, okay? Let's go into that directory. Let's have a look-see around what's going on here. This directory here called .git, that's my repo. This is the database on my PC, the cloned repo right there, all right? And these three files here are the current, latest, greatest files from the repo, so I can edit them, all right? So this is the database, and here's my copy of all these files. I can type git status, and it'll tell me you're currently on the master branch, or sometimes it might say the main branch here. You're up to date with the origin master branch over there. You didn't do anything, so there's nothing to commit, and everything's clean, all right? This would make sense, because we just cloned it and didn't touch anything. Okay, now, what we're supposed to do is we are supposed to convert, we're supposed to make sure that when we edit our files, remember, we want to be on this development branch, all right? So let's look and see back over here at the higher level directions. So what's going on here? This is the, this is the assignment you're supposed to accomplish. And these are the one step at a time instructions on how to use GitHub, right? Right now, we should merge this document together. But what we need to do is create, we already created the development branch on GitHub. I'm reading the old one here. We cloned it. We need to say checkout development, all right, on our local copy And what this does is it switches you to this other branch. If you type git status now, you'll see I'm on the development branch. And I'm up to date with the development branch on the origin repo as well on GitHub. Now, if you forgot to create the development branch on GitHub before you cloned this, this here would not work. And this would, you'd not be on the development branch, right? So if you get errors when you do this, what you can do is go back up here. I mean, the simplest, straightforward way to do it is to just delete this whole thing, this copy on your PC, go back to the GitHub repo, and do what you should have done in the first place, and that is to create this that you saw a minute ago, all right? So in a future assignment, if you forget that step, that'll be the key. When you're doing this, this would fail, all right? Because there isn't one, all right? And again, do it in the order I showed you. Otherwise, there will be a synchronization problem when it goes to pushing this stuff back into GitHub, all right? Okay, so we've checked it out. All right, so we did the clone, and we did, if we go to Git Status again, we switched ourselves over to the development branch. Okay, now we're ready to edit files and do our homework. What are we supposed to do? Edit your files and then add them, and then we're going to commit them. All right, so let's go back over to the homework assignment description and see what we're supposed to do. Commit it as follows. Add the following doc box and then push the thing back to the repo and the commit and so on. All right, so here you're supposed to do. You're supposed to add a doc box to the code that we're giving you. So here's a C++ program called intro. I'm going to use Vim to edit these files because most editors upset me. I've been using this thing for 35 years. All right, so while I can't do it so well while I'm talking, I can move around in here faster than most other editors, all right? Supposed to put your Z number in here. Z1, 2, Z4, 5, very good. Course, section, and section number. All right, so I'm in comp sci 340, section 2, and I'm not cheating. Thank you very much. Okay, then what does it say to do? Then add the code. This commit will result in a lower, what are you supposed to do? The comment will be modified to reflect all this stuff. This should be at the top of every file that you do. You don't do this and we drop you a letter grade. And basically, we don't know who you are, okay? If you submit an assignment and don't tell us who you are, you're wasting our time. Because if you have a login that's, you know, ABC Melvin, how do I know who that is, right? So put your name and your C number in here, otherwise we can't assign you a grade. All right, so what are you supposed to do? Now we're supposed to add some more code down here. We're going to put this line of code in here, and yes, this actually has a typo in it. Leave the error and everything in, okay? Because it simulates reality, right? In other words, you're never going to write a perfect program on the first try. With all due respect, pretty much no one can, all right? So what's wrong with this? We misspelled C out, all right? So that's what we're supposed to do. Then create a make file, all right? That's going to build an executable called introduction. The make file must produce this thing when we type make with no arguments at all. Okay, so what we need to do is create a make file. All right, I use the capital M style make files. You can use uppercase or lowercase. All right, simplest way to create an executable file from a C++ source code file when there's only one file in your entire project is that right there, okay? This uses all of Make's default rules, and Make already knows how to compile a C++ program and to store the output in a file of the same name without the trailing .cc, all right? That would accomplish the task at hand. However, this is going to be annoying if that's all you do, okay? You probably want a way to clean up your mess when you're done, so I'm going to add a clean rule, okay? So I can type make clean and have it delete the output, the binary executable, right? So if I type make clean, it would delete it, okay? Assuming there was one there in the first place. which in this specific moment there is not because we have an error in our program, right? It didn't compile. Now, I usually do a few other things in here too. This up here is the name of the variable that by default holds all the flags for the C++ compiler. And I always type in WALL, WError, right? Unless you're super duper advanced programmer, and let's face it, none of us are, you should never see one error or one warning of any kind from the compiler ever. None of us are using anything so esoteric where we need to avoid or ignore any warnings, okay? And WALL says, warn me in any event of even the slightest discrepancy that could get me into trouble. And this over here says, treat any warning as if it's an error. In other words, your program won't compile if you so much as do something even at a warning level, okay? And this, to me, will save you, it saves me a ton of time, and it will save you a ton of time as well, all right? Because by saying WALL here, you're going to get all kinds of warnings that you don't otherwise see, and the make will simply stop right then and there, so you can fix your program. Most students that come to me that ignore warnings usually waste all their time trying to ask me what's wrong with my program, followed by, well, let's look at the warnings, and it'll tell you what's wrong with your program. You could have fixed it, days ago, hours ago, whatever. You don't have to wait to get a hold of anybody to ask any questions, all right? Trust me, the compiler does a pretty good job, all right? And in this case right now, it says cut was not declared in this scope, right? It's an undeclared variable name. And it turns it red, gives you a highlight, tells you what line number it's on. If you can't find that error, then you're in deep trouble, okay? All right, so I digress. What do we do now here? You're supposed to do that. Then we want to add the makefile to local repo, commit the changes, and push them back up to the remote repository. Okay, so where are we? Let's clear all the mess off the screen. I'm constantly typing in Git status just to get our bearings here. So what's going on right now? It's going to tell me I've modified this. Yeah, I remember having done that. And it says, hey, I don't know what to do with this because it's a file that was never in the repo before. If you want to add it to the repo and commit it, type git add followed by this file name. Down here, the Git is wonderful, right? Just like the nice warnings in GCC, G++. Says, hey, I don't know what to do with this here. You've modified it. What do you want to do? I can type git add followed by this file, and I can add it to the a staging area so that it can be committed back into the repo. All right. Now, there's a bunch of different ways to do this. You'll see as you go along. And you'll just develop your own style. What I like to do, and what you pretty much need to do, I'm going to do these separately. Why? Because the modifications I made to introduction.cc have absolutely nothing whatsoever to do with the fact that I added this makefile. And you'll see in a second kind of how this thing works. I'm going to git add introduction.cc. What does it do now? It says, okay, hey, this is staged here. And it will be committed. All right, this is still, I don't know what to do with this thing. You didn't tell me what to do with it, so I'm not going to do anything. Okay, great. The red files, nothing's going to happen at all if I try to commit right now. The green ones are all going to be put back in the current repo on the current branch. All right, so this is the key here. If I type git commit right now, and I don't, there's a short form of the command. I think Mike put that in the handout. You could do this if you want to. Personally, I think this is a bad idea. And the reason I think it's a bad idea is when I type in just git commit like you just saw me do, what it does is it shows me the status in all the files that I'm committing right now to remind me. Normally you'll have a whole lot of stuff going on in here. And what I like to do is look down here. Does this thing represent what I think I'm supposed to be doing right now? If the answer is no, get out of the editor immediately. And in Vim, you just type :Q. And then what'll happen is it'll say the commit was aborted because you didn't tell me any helpful message, all right? Remember when I said every time you commit something back into the repo, you have the ability to put a little log message in there. Well, if I didn't give it one, the commit is aborted, okay? Beautiful. All right, it gives you a chance to double check your work. When I'm collaborating with people that don't put good git commit messages in there, it makes the job much harder, okay? You can clean up your mess is the point if you keep your eye on it as you go. All right, so this is great. So what did I do? I added a doc box and a print line, all right? This is so trivial. It's actually kind of hard to explain, right? Okay, so there is what I did to that file. Let's do a git status now. It disappeared, right? This thing, it has nothing to say about it. Why? Because that's been committed back into the repo. The summary of things that are, not in sync with your local repo right now is the fact that you got a make file sitting there. Okay, I'm going to git add make file. Now, I'm not saying that you need to add each file one at a time. What I am saying here is that if you want to put a different message on why you added this make file, then the message on why you edited, introduction.cc, you have to do 2 separate commits. It's as simple as that. So added make file, all right? Well, everyone knows it's been added at this point, but okay, that's going to be my log file, all right? Or my log message. Okay, so now I'm all the way down here. Nothing's left to do. Why? Because all the modified files and new files have been put into my local repo. What does it say here? I'm still on the development branch. Your branch is ahead of the development branch on the origin server by 2 commits. Well, that makes sense because I just did 2 commits and I'm ahead. All right, so my repo, it has additional stuff that's not in GitHub. So it says type git push to push your stuff back to the origin. Okay, so I'll do this. I'm going to have to log back in again. And it pushes it back over there. All right, now a real GitHub user would use SSH with shared shared public and private keys, so that you don't have to type your login password in all the time. All right, Google around. There's some help and README files in GitHub. I'm not going to go over that in this video. If you do it this way, it will always work. If you do it the other way, you can optimize your workflow. That's all I'm saying, okay? If you do another git status right now and you type git incorrectly, you can see what's going on. I'm on the branch development. I'm up to date, and everything's clean. It looks like it just did before. Okay? Now, let's look at another new command. Git log. Show me the log of all the messages. All right, let me clear the screen so I don't have a big mess in there. Git log. What am I looking at here? This is the oldest message. This is the newest message up here. What is all this junk? This is the ID number that represents the version of all the files at the current at this time in my repo right now. This is the newest version. And what did I do? I added a make file. In this commit, I added a make file. There's my message right there. Here's who did it. This is the current time. Okay, you see over here the head node right now in the development branch on my local server, right? Which represents the development branch on the origin repo upstream, as we say. Okay, the previous commit, whose ID is this thing, done by this guy at this date, and the message affiliated with that is added a doc box and a print line. All right, before that, someone else did this down here. This is the thing that we cloned. When we cloned the repo from GitHub, somebody else, your teacher, whatever, already did a commit over here. And what their message was this is my initial commit. The very first commit of the entire thing, usually there's nothing to say about it other than the fact to say, I'm committing the first files, all right? No big deal. Once you get going, though, you need to have more meaningful commit messages, all right? So these are these IDs of each version of your project, all right? And it's not an ID of a file. It's an ID of all the files in this entire database here. Now, let's go back to GitHub, as we just did the push, and have a look-see around. Okay, so this moves on to, okay, now that you're done, do some other stuff. We'll come back there in a minute. Let's go back to our repo over here. All right, what's going on here? Well, development had recent pushes less than a minute ago. I just did that right now. Okay? I can compare them. So this is kind of like reloading and keeping up to date with what's going on here. At least it is up here. Let's reload this page. All right? Click your little reload button or hit Control R and stuff like that. This down here didn't update until just now. So what happened here is you can see what I did to these files down here. So this shows me the latest greatest on the development branch. If you're stuck on the master, flip it over again like we showed before. So what's the difference between what it was and what it is now? Is this compare and pull request thing, all right? If I click this right now, what I'm going to be doing is handing in my homework, okay? Don't hand it in yet. We're not done yet, all right? Let's go back down here to the README file. This is the latest version, and I didn't modify the README file, so let's see what we're supposed to do now. It says, you know, add the make file, you execute the make command, and then correct the errors, all right? When it's ready for grading, then do the commit and push. Like I said, that's the green button on the top. Okay, so we put it all in there with the error and everything. Now let's fix it. Now, let's say that we're, you know, egomaniacs and we think everything's great and our lives are perfect and we don't even need to test it. We know there's a bug in there because we ran it and tested it before. But let's say we don't do that and we're so confident we're ready to hand it in, all right? Let's go over to Hopper. And log in there and test it on Hopper. Remember, your programs have to run on Hopper or Turing, okay? So I'm going to like make deer over here. This is my first time for this class I'm logging in, all right? Ooh, there's a lot of junk on there. I got some stuff in my logins, but, you know, I've been using this machine for other things here. Let's make a directory. What am I going to do? 340. Put my files for 340 in a new directory because I got all this stuff for 463 and I got spring and fall and previous semesters. So let's not make a mess of all these other things. Clear this out, make a nice new directory within which we're going to do our stuff here, okay? Now, what we're going to do is clone it onto Hopper, right? And we talked about this before. What do we need to do? Same thing we did on my home system, right? Git clone, right? Go over to your repo. Get the thing you're supposed to clone out of here, all right? Clone it onto Hopper. Log in again. All right. Again, I have a repo in here now in the database files and everything else, all right? Git status. I'm on the master branch. Remember, git, checkout, development. This switches me over to the development branch on my local repo. We talked about this before. Let's rerun the git status command. Now I'm on the development branch. I'm still up to date. Now, look what we did when we first cloned it. Where's my make file? It's not there because I was on the master branch. The master branch is older than the development branch, right? So I switched over to the development branch, and now I got all my files in here. So don't ask, my files went away. You need to be on the right branch. This is somewhat unfortunate, but you need to move around independently on each one of your different machines that you're working on. Okay. And I was so confident when I committed my files, I knew there wouldn't be any error. Oh no, there's an error in my thing. So we got a couple of options, right? We can either go back to my home machine, fix it, push it, and go back and forth that way, which wastes all this time because you gotta have to be pushing and pulling and all that other stuff. Or I can just fix it right here on Hopper and get it to work while I'm testing it on Hopper. Oh, yay, it compiled this time, right? Let's run it and see what happens. Yay, it works. Okay, now, what did we do? You can type git diff. Remember we were looking at diff before. This is what we call a context diff. Remember the greater than, less than signs when we just did a simple diff? This is what we call a context diff. It gives you the two lines here. It's going to say plus and minus. It doesn't really matter. Instead of greater than and less than, it's the same thing. And it gives you some lines around the lines that are different, okay? So what we see here, okay, so how do you read this diff? The minus means in this file introduction.cc, the one that I am focused on, the one that I have a difference in, the one that I just edited, I deleted this line and replaced it with this line. Okay? Now remember earlier I said that your style of development will have an impact on how you think of what's changing here. Remember, diff lists entire lines. It does not list, in your program, it doesn't know that this is a single expression or a statement. It looks at it as text, okay? So one of the things you need to think about is if you put a lot of stuff on one single line, when you're looking at the diff like this, it'd be nice to be able to recognize what really changed, okay? So what I try to do is not to make these lines too long. This one's obvious because you see it shift by one character in here. And obviously the CUT to see out, right? Okay? I'm just saying you should get used to seeing this. And then when you actually type in your code, you'll start thinking about how, when you're looking at a diff, whether recognizing what changes over time is going to be easy or very difficult to do. This change is so trivial, it's actually, again, kind of hard to really talk about or appreciate in that capacity, all right? But let's just start thinking about that as you go, because your choice of how you lay out your code will make this easier to read or harder to read as you go, all right? That's all I'm saying. So where are we at? We go to Git Status. We said, oh, look, I modified this file. Add it if I want to commit it. Okay. Also says there's a new file sitting here now. What do you want to do with that? This doesn't belong in a repo. Any file, anywhere, anytime in a project that is generated by make or something like that, you don't put that in the repo. The whole point is you give the person the source code and they compile it for themselves, all right? If you put this in the repo, all you're going to do is upset everyone else you're working with in your project. Don't put this in the freaking repo, all right? It's wrong. What you want to do is a couple of things. That's what this file up here is for. You got a couple of options. If I type make clean, remember the clean rule cleans things up. And I type git status, looking better here. I don't have this extra junk file, right? Don't put it in the freaking repo. I can also say this. This is what you really want to do. Don't just try to always be careful all the time. That fails miserably. Because you're going to be in a hurry and you're going to forget to do it once. If you put a file in here, or like star.a, star.o, star.smod, and we've given you a lot of defaults in here, right? But by default, GitHub doesn't know what you're going to really, the names of your output files and stuff like that. So as you create what we call a target file, add it to the ignore in here, okay? So if I make it and I type git status, I'm not going to be wasted. My time isn't going to be wasted trying to figure out why that, should I add that? Should I not add it? How do I get it out of there? You'll never see it again once you put it in the git ignore file. Now, because I modified the git ignore file and that itself is in the repo, now I have that file that's been modified as well as my source code. So what am I going to do? I'm going to say git add the introduction.cc file, and in here I'm going to say git commit. Now remember, I'm on Hopper, not on my home system. I say fix typo in print line or something like that, something useful. All right, git status. I'm going to say git add. Now you could do all this at once, but think about it. What can you say about both of these files that's relevant here? You can't, because what I did to git ignore has nothing to do with the introduction.cc file, right? So I'm going to say added introduction. Why? Because that's what I did. Now, this is going to be obvious from a diff also. Oops. All right. Oops. Jesus. It's so hard to type and talk at the same time. Sometimes. Okay, this should not be a shock whatsoever. I've committed 2 things in my repo on Hopper here. Okay, so what am I supposed to do? I can say git push just like I did on my home system. Now what's happening? Let's make sure we know what's going on. I've modified the repo on Hopper. I'm now pushing it back to GitHub. Now, Hopper and GitHub are synchronized. Their repos on those 2 systems are identical right now. Okay? And it runs on Hopper. It built, it ran, and all that other fun stuff. I suppose it would be foolish to submit it without ever having run it. So let's go back to Hopper and run it. I mean, I'm supposed to be showing you what to do here. You'd be a fool not to try and actually run it after all this. Okay, it's still sitting here. It's still compiled. Let's do a make clean, right? Because you may have forgotten it. Maybe it's an old stale file here. Latest, greatest one. All right, let's run it. Make sure it works. Woohoo! Yay, it works. Okay, great. Now, we've already committed all this stuff. We pushed it back to GitHub and all that stuff. Again, we can type git status, and there won't be anything to do. Okay, great. Now, come back to your home system, right? Where are we at here? Type git log. We can do the usual things. Look what's going on in here. These are the 2 commits I did in a home system. It does not yet show the stuff that's on GitHub. Why? Because I didn't pull it down. I didn't bring it back from GitHub to my home system, right? This is my home computer. Let's go back here to GitHub. All right, I've been yakking and clowning around here. I'm going to hit Control-R to refresh this page. What happened now? Okay, I updated the git ignore. I fixed a typo in the introduction file. And I have recent pushes again, okay, in the development branch, okay? Great. So this one's up to date with Hopper. Git pull. To bring the latest, greatest stuff down and merge it in with what's on my home computer, all right? Now, of course, you don't have to bring it back to your home computer. For all intents and purposes, we could just blow away this whole set of files on my home computer right now because I'm done with the assignment. Do I really need to keep a copy at home? I don't know. Personally, I like to keep an extra backup to make sure that all is well. All right, so that's what we've just done here. Now, all 3 of these repos are up to date. If I type git log again right now, I can see I added the introduction to the git ignore file. I fixed a typo on a print line and all this other stuff. All right, this is all the messages. You can also see that on GitHub if you want. What do we do here? We got 5 commits. See if you click here. You click around and explore what's in here, all right? You may not want to actually edit anything and change your settings because you could break your thing. This is really the git log, okay? And if you click on this thingy over here, these are an abbreviated version of those giant hexadecimal numbers, okay? And it'll come up and it'll show you the context diff. What did you do here? Well, you edited the git ignore file and you added some blank lines in this, all right? This is kind of a nice little viewer thing, right? Okay, what happened when I did this thing? When I said fix the typo in the print line, what happened there? Well, you edited a file called, oops, I shouldn't have clicked that. You edited a file called introduction.cc. You threw away the red lines, you added the green ones. Again, this is on a whole line basis. All right? Think about how the text in your file is organized when you write it, your program's in the first place to make this more readable. All right? I'm jumping ahead here. That's kind of an advanced thing. You'll kind of learn this as you go. You know, if I make a change like this, it's going to look really messy, and I'm not going to recognize what I did when I look at a diff, right? It's, again, think about this down the road more so than now. But I want to put it in your head because I want you to notice it. Sometimes you'll look at diffs that some people write and commit to these repos that are a disaster area. And you can't really figure out what's going on, even with all this help. All right? That's a disorganized person, okay? You don't want to be that person is all I'm saying. All right, so this allows you to see the various changes and stuff like that. Now, if you want to see all the files and more information in here, because really I'm looking at the messages, I added an introduction, right? To what? I don't know. All right, so you can type git log --stat, okay? If you do this, what it'll do is it'll add this other stuff down here. It'll say, oh, I added an introduction. To what? Well, you modified git ignore. I added 3 lines. That's what it means. I have one file that changed in this commit, and I had 3 lines inserted. What happened down here? I fixed the typo on a print line. Well, I modified this file here, changed that one. I added a line and deleted a line. Okay? In other words, I added one letter to a line of text. And again, diff looks at that by throw away the old line, put in the new one. Okay? What does it mean when I add a make file? Well, I changed it from nothing to something, and its entire contents was inserted and nothing was deleted. That all makes sense, right? Here's the added a doc box. Well, I added a bunch of lines and I deleted one. Remember when I did that? I deleted the comment that was there and replaced it with a doc box, right? Added 8, deleted 1. Here's the initial commit. I added all these files, okay? All this should make sense. Now, if we really want to, I can do things like show me the difference between this and this, right? Honestly, this is easier to do by going into GitHub. But in the command line, inside GitHub, all this thing is doing is running the Git commands that we can put on our own command lines if we wanted to, okay? So what I'm talking about was this one right here. If we look at this, you'll see the one line go away, and then these other, 6 lines were added, right? We also added this one, right? The typo and the doc box, right? Now, inside on your command line, you can do this if you want. Git diff, I think it's this. And then you put 2 dots, and then you put this one. Show me the differences between those 2 versions. Now, if you type git and spell it right, it works better. Okay? This is exactly what you just saw in GitHub if you want. All right? Again, anything you do in GitHub, you can probably do on the command line as well. All right? This is just some fancy schmancy GUI, number 1. And number 2, it holds a copy of your repo. It's a third party. All right, so let's hand this thing in. We've beat this point to death. What are you supposed to do to hand it in? All right, go back to the directions. Completing the assignment and pushing all your stuff back to GitHub from the local repo, and we tested it on Hopper. It's not good enough it works on my PC. It has to work on Hopper, right? So you got it all up to date, right? Everybody's happy. So what do you want to do? And you verified it's all good. I need to create a pull request to tell the TA to grab my assignment and grade it, okay? You can find the pull request by clicking on the bottom, on the button that says branches, and then clicking on the new pull request. You will not accept the pull request. If you accept it yourself, the TA won't see it and he won't grade it. Okay, so do exactly what I'm showing you right here, okay? Now, you can do compare and pull requests. You can click on these branches over here, like the handout says, and down here you can see these pull requests. Make a pull request on this. Well, why do I got 2? Well, here's all the branches, and this is the active branches, right? Well, there's only going to be one branch, okay? And this is the current one that's active. It just so happens to be the same one in both cases. Come over here and say new pull request. Don't delete it. Okay, you will have just deleted all your homework. Okay, so new pull request. All right, now what are you doing? Looking closely here. I have the development branch, and I want that to ultimately get merged into the master branch or the main branch. Okay, and it says it can merge it, and that's great. It better be able to do this. Otherwise, the TA can't grade it. So this is in the development branch. Make a comment. All right, handing in. Assignment 0 or whatever this is, okay? And I can create pull request. Now, once you've done this, you're done. If you scroll down here and you click this, your program won't be graded. Honestly, I'm not sure you can do that. It may be one of those things that I can do because I'm the teacher, because I can merge my own stuff. You might not be able to do this. I don't know how it works for you, okay? So one of these disorienting things. I don't know what it looks like to a student. Let me know in the comments below if you want. But regardless, do not merge it yourself. That's the job of the TA. So this program is done. It's committed. We've synchronized a couple of different repos. We did commits. We looked at the log files. We looked at the diffs and all the other stuff, and we handed it in. All right? I'm done. We can close this thing out and walk away. Now, this handout is on the course webpage, and you can recognize this flow chart. This is what we were looking at in the previous lecture here. When you accept the assignment, you can then view the repo in the GitHub. This is a little review of what we just looked at today, right? You can create a development branch. You cloned it, and there's this loop. Kind of an interesting way to show it, but that's fine. How do you do the assignment? You add and edit files, commit, and then you go around this loop. And when you're done and happy, you push it back to the GitHub thing. Now, in our case, what we did is we then went over to Hopper and did this again. I really wanted you to see what happens when you develop on one machine and test and develop on a separate machine, because that's going to be a very realistic thing that you're going to have to be able to do. All right. And that's what we just did in this lecture. If you do every bit of work on Hopper, or you're foolish enough to think that if it runs on your own machine at home, that it will run on Hopper, you can do this only once and not have that extra repo and the pushing and the pulling that was involved in getting it from Hopper back to your PC. That's fine and dandy, but that's a little bit naive, okay? I'm sure it is. When you're totally done with everything and everybody's happy, you do the you create the pull request. Thanks for watching. I hope you were able to finish your assignment in its entirety in real time while we were going through it all in this video. See you next time. Bye.